we want to find a relative maxima and minima of this function, x minus 2 cubed times x plus 1. To find a relative maxima and minima, the first thing you need to do is to find all the critical points and then analyze the critical points using the first derivative test to see whether each critical point is a max and min or, well, not at all. So to find a critical points, we have to take the derivative. When you look at this function, here we have sort of this function is split in two right here with a multiplication, and so we really need to use the product rule. The product rule said we take the derivative of the first one, that's x minus 2 cubed. To do that, we need to do the chain rule. 3x minus 2 squared times the derivative of x minus 2, which is just 1. So I guess we don't actually have to write that in. Times x plus 1 plus x minus 2 cubed, the first one, times the derivative of the second, which is just 1. So we don't have to write that either. To find the critical points, we set f prime equal to 0. So that means that 3x minus 2 squared times x plus 1 plus x minus 2 cubed equals 0. And in order to solve this equation, the worst thing you can actually do is to multiply everything out. When you use the product rule or the quotient rule, it's important to note that you already have these products and essentially things are factored for you. So you want to just use this momentum that the product rule gave you and continue to factor this further. Here, the common factor is not just x minus 2, but really x minus 2 squared. The second term has more than that, but it just means something will be left over if we factor out x minus 2 squared. So if we do that, in the first term we're left with 3 times x plus 1. And in the second term we have 1x minus 2 left. So this is good, we're factoring this. And now x minus 2 squared is already factored, we don't need to do that. The second term, I guess the big term, we want to combine everything. Right here we have a 3x plus another x, so I guess that would be 4x. Distributing the 3 amongst the x plus 1, that's 3x and plus 3. So we have a plus 3 and then we have a minus 2, so that would be plus 1 equals 0. And each of these factors gives us a solution to this equation. First one, x minus 2 squared, gives us x equals 2. Even though it appears twice, there's only one critical point. And 4x plus 1, if you can't see that it gives you minus 1 over 4, you can just set 4x plus 1 equal to 0 and solve for x. But if you can see that, it's a pretty quick thing. And once we have this, we want to do our little sign chart as usual. X and f prime. And we want to plug in some values in these intervals determined by the critical points into f prime to see if f prime is positive or negative. In turn, that will tell us whether f is increasing or decreasing. It's probably not a good idea to go and plug the whole thing back into, this f prime of x, because there's a lot of stuff going on in there. Maybe easier to plug them into this sort of factored f prime of x. So let's do that. A good number after 2 to plug in, I suppose, would be 3. If I plug in 3, I get 3 minus 2, or 1 squared, that's positive, times 4 times 3 plus 1, that's 13, that's positive. So that's f prime's positive here. A good number between minus 1/4 and 2, that would be 0. If I plug in 0, I get 0 minus 2 squared. Well, actually, it doesn't matter what I plug into the first term. Since it's squared, it's always going to be positive. And in the second one, 4 times 0 plus 1, that's positive 1. So positive times positive is positive. If I plug in, say, negative 1, the first term, once again, x minus 2 squared is positive, but 4x plus 1 now becomes negative 4 plus 1, so that's negative. Now we use the first derivative test, which basically just means we look at each of these critical points and see what's going on before and after it. Over here at minus 1/4, the function was decreasing f prime's negative before it, so the function goes down to f of 1 minus 1/4, and then it leaves it by going up. So if you go down and then up, that means it's a relative minimum. And at 2, the function is increasing both before and after. F prime has the same sign before and after 2. That basically means that f of 2 is neither a max or a min. The sign of f prime has to change at that critical point for you to have a relative maximum or minimum. So the answer to this question then is the relative minimum occurs at x equals minus 1/4, and that the relative minimum itself is f of minus 1/4. So you would need to plug minus 1/4 back into the original function. It's not too hard. That's minus 1/4 minus 2 cubed times minus 1/4 plus 1. And so that's negative 9/4 cubed times negative 3/4. Oops, sorry, positive 3/4. So the answer is going to be negative 9 cubed is 729. So 729 times 3 would be, let's see, 729 times 3, 27, 28, 21, 2187. Over 4 cubed times 4, that's 16 squared, or 256. And this is really as simplified as we can have it, so that's it. That's a relative minimum. And just for completeness sake, this we can write down there's no relative maximum, because you only have 2 critical points and neither of them relative maxima. So here's the answer, and kind of the 2 things to remember in this problem are that 1, critical point does not automatically mean rel max or rel min. And also, when you take the after you take the derivative, try not to simplify or combine just yet. You take advantage of the product rule and use that to help you factor the derivative.